Hello everybody, in this video we are going to continue the conversation about exponential functions. Specifically, we're going to actually focus on writing exponential functions from word problems. So if you remember from the previous videos, we talked about the form of an exponential function and what each one of those numbers or letters represent. So we are actually going to need to use those forms to be able to write and plug in numbers in the appropriate places. Once we determine what the formula is that we're going to use, then we can then use that formula to be able to answer the question in the problem. So let's go ahead and over here to the side, right here where it says writing exponential functions, I'm going to go ahead and write the form that we're going to use. So just to remind you, f of x is just the name of the function. It doesn't have to be f of x. It could be y or anything else. But the one that is very specific to the exponential function is the a. This is our starting point, our y-intercept. Our b is going to be the rate in which something is changing. So depending on whether it is going to be exponential growth or decay, that is going to tell us what direction it's going to go in. So this is going to be the rate in which it's changing, and this is going to be the starting point. Our x is going to be most likely time that is passing or some other number that's going to be given to us. So let's go ahead and look at some of these word problems together to see if we can set up the equation and then answer the question. Alright, so let's look at this one. It says a rubber bouncy ball is dropped from a height of 101 inches onto a hard flat surface. After each bounce, the ball returns to a height that is 16.1% less than the previous maximum height. Write the exponential function that best represents the situation, then determine the maximum height after the 10th bounce. So we need to look at some of the numbers that have been given to us. So we know that we're specifically looking for the initial value, where it starts, and then we're looking for a rate. Now this is going to be part of the question that's being asked for us to find. So the number that they're asking for is going to be our x value here. So the second thing that we need to determine after we figure out which numbers need to go where is whether this is a exponential growth or an exponential decay, because that matters. And we also need to be able to take any percentages and turn them into decimals. So if you forgot how to do that, I'm going to go ahead and remind you how to do that. So with that being said, let's go ahead and go through here and see if we can pick some of that key information that we're going to need. So the bouncy ball is dropped from a height of 101 inches. So this automatically tells us where the ball starts. So that is going to be our a value. That is our starting point. Then it says that every time the ball bounces, the height is 16.1%. So that right there is going to be the rate because it is a percentage. And then the second word that's going to be important to us here is that it is going to be 16.1% less. So that word less automatically lets us know that this is not growing, it is decaying because it is decreasing by this percentage. So with that being said, we're ready to set up our equation. Now for that, we're going to say f of x is equal to 101, that's our a. And we're going to say 1 minus b to the x power. Now the reason I put the b here is because remember our b is given to us as a percentage. We need to be able to change it to a decimal. So with that, we're going to have to move our decimal 2 spaces to the left. So I'm going to show you 2 ways to do this. You can take your decimal and just move it over 1 and then 2. So that means that our b value would be 0.161. Now, if you find that a little bit difficult to remember to move it to the left, You can also take your calculator, take 16.1 and divide it by 100. If you divide a number by 100, it will automatically move the decimal space 2 units to the left. So notice that it gives me the exact same thing. So there's 2 ways you can do that. Alright, so because it is a decay, we're actually going to take our rate and subtract it from 1. If this was a growth, we would say plus 1. So let's go ahead and rewrite it. 101, 1 minus 0.161 raised to the x power. And so I'm going to do that. I'm going to take what's in parentheses and do 0.161, and we get 0.839. And so this actually matches up to everything we said. We know it is a decay problem because of the word less. So that tells us it's a decreasing. And if I look at the equation, we know that the number inside the parentheses, or b value, is a number between 0 and 1. So that also matches up with what we know about a decay function. And then from here, we can just figure out what they're asking us for. So the question says to determine the maximum height reached after the 10th bounce. So the 10th bounce, that number 10, is going to determine the number that we need to plug in for x. So this one's going to be x. And so I'm going to write it out first. I'm going to say 101 times 0.839 raised to the 10th power. And then from here we can just type this in. So we have 101, 0.839 raised to the 10th power. And so for this one it's going to be 17.4558. And so it doesn't really tell us if we need to round it. So let's go ahead and write it in. 17.4558. And then this is going to be inches. Okay. Alright, so we should be able to do the exact same thing with the second problem. So let's go ahead and look at that one and see if we can pull out all the information that we're going to need for this one. So this one says an employee receives a 3% raise once per year. If the employee's initial salary is $69,400, write the exponential function that best represents the situation, then determine the employee salary, what the employee salary would be after 8 years. So for this one, our percentage is 3%, so that's going to be our B value. And we know that a raise is an increase of how much you're getting paid. So with that one, we automatically know that this is going to be growth and not decay because it should be increasing. We also know that our starting salary is going to be the $69,400. So that's going to be our A value. And then from here, it wants us to determine what the employee salary would be after 8 years. So this is actually going to be the X that we have to plug in to determine our answer. So because this is a growth, let's go ahead and write it out. So we know it is going to be, so this number is going to be kind of big. So that is our initial. We're going to say 1 plus 0.03 x. And remember, we have to take our percentages and move the decimal place over. So for this one, it doesn't have a decimal, so we know it's at the end of our number. So if we move it over, we would have 0.03. And I remind you that you can use your calculator if you get confused. So if you do 3 divided by 100, it gives you 0.03. And then all we have to do is plug in the 8 right here. So I'm going to rewrite this. And that is 1.03 raised to the 8th power, because that's the 8th year. And then if we type that in, it should give us the answer we're looking for. So I just typed mine in, and it looks like this. So that tells us that it should be 87,913.80 cents. And we're talking about money, so I'm putting a little dollar sign right there. So in order for you to be able to answer this question, we have to figure out where those numbers go. We should be able to take a percentage and turn it into a decimal, so we can put it in our formula. And depending on whether it's growth or decay, we should be able to take that percentage in decimal form and either add it or subtract it to the 1. Once we do that, then we can just plug in the numbers and find the answer that we're looking for. Alright, so we do have one more example, but I'm going to go ahead and put it in the next video. So I hope that these two examples that we worked together have helped understand how to write an exponential function and then use that to be able to answer a real world problem. The next set we're going to look at is just one more question, and it's over exponential regressions. How do we take this graph and be able to write the equation from this graph? So I'll see you guys in the next videos.